Hello, students. What this begins is a lesson on what we just generically call eudiometers. They could also be called gas collecting vessels or gas collecting tubes. This video will allow us to learn what a eudiometer is and how we utilize it in chemistry. So, just to give some overview. Remember in lab when we collected gases. So the lab where we collected oxygen, collected hydrogen, and then tested it for different properties. Well, think about our bottles and our test tubes. And we had those samples of gas collected. What could we measure about them? Well, they filled the vessel. So if we know the volume of the vessel, we know the volume of the gas. We can measure the temperature of them. They're in contact with the classroom. So if they were sitting in the classroom, then we'd say we could get their temperature. Could we get their pressure? That's what a eudiometer or a gas collecting tube allows us to do. I will just refer to these as eudiometers from this point. A eudiometer is pictured here. So eudiometer, you can imagine, the left photograph shows one of our eudiometers laying on a lab bench. And it's hard to get the perspective. It's like a very long test tube. And what I have shown at the right is what's quite nice about a eudiometer is there are graduations. So like a graduated cylinder, depending upon how much gas is filling the eudiometer, we can actually measure its volume directly by the markings on the vessel. So in our gas collecting lab, remember we filled our vessels with water and then we bubbled in gases. So imagine we are starting on the left. I just put some food coloring, blue food coloring into water so that we could see the beaker with food coloring and the eudiometer with food coloring water filled with water. Now you can see it's almost a meter high. It's really, really long. And the eudiometers that we have are graduated to measure from the top to 50 milliliters. All right. So imagine we did a lab and it produced a gas, and then if we go to the right, we know the gas being lower in volume or lower in density than the liquid, it would float to the top and push out the water. So of course, the opening of the test tube is turned beneath the surface of the water, and so as gas is being collected, it pushes the liquid out into the beaker, but then we have a trapped sample of gas. How on earth do we get its pressure? Well, now let's transition to the student note packet. What we need to talk about first is we need to apply our imaginations and pretend like we had our green bins filled with liquid mercury. Imagine we have 3 eudiometers. So these would be the opened, so very long test tubes, and we filled them completely full with mercury. Then we overturned them, clamped them, and then trapped samples of gas. And what we're encountering is this middle eudiometer has gas collected just until the liquid level inside is equal to the liquid level on the outside. I know you can imagine that based upon the lab work that we've done. To the in this direction A, can we imagine that we've collected gas, but it's stopped here, and so the liquid level inside is higher than outside, and we could actually take a ruler and measure that height. And then the opposite is seen here. Imagine we almost filled it just a little bit is still filled with mercury. And if we could measure 30 millimeters below the surface, it's just for sake of comparison that we chose to call this 30 and 30. So just imagination, they could be all kinds of different measurements. All right, a eudiometer allows us to indirectly measure the pressure. Indirectly. Well, how? Well, whatever gas we've collected, we know that gas is colliding with itself and the walls of the eudiometer. Well, where else is there gas? On the outside here, the atmosphere. Do we have a measurement of that? Well, atmospheric pressure, we can get the measurement from a barometer. A barometer. And so we'd look to a barometer to tell us what the pressure on the outside is reading. Well, what does that have to do with anything? Well, that is what is pushing down on the liquid on the outside. Well, this worksheet tells us that a barometer was read and it is 740 millimeters of mercury on the outside. Well, if the liquid level is the same on the inside and the outside, imagine the force pushing down. That's pushing on the outside. Well, the gas that you've collected is pushing on the inside. And if the levels are equal on the inside and out, doesn't that mean the force is equal? And so if the outside pressure is 740 millimeters of mercury, meaning the forcefulness can support a barometer that we would measure to be 740 millimeters of mercury, well then, can't we make the comparison that if that's what the atmosphere is reading in a barometer, if the liquid levels are the same inside and out, it's mercury here, it's mercury here, it's mercury here. So we would say that the gas inside of tube B is also exerting a pressure of 740 millimeters of mercury. If you're doing a lab and you're looking to the limiting reactant to create a certain amount of gas, how likely is it that the lab will give you perfectly enough gas to lead to equal liquid levels inside and out? It's not very likely. So this is unusual. We usually have the case like we see in A and C. So let's go to A. Okay, we still know that the outside is 740. Well, the inside is less. So think about, okay, which is stronger? Whatever is stronger will lead to the lower liquid level. So that means the inside pressure is less. So we definitely know tube B, or tube A, I'm sorry, it's going to be less than atmospheric pressure because it can't push down as strongly. Well, if this is where a height of 740 in a barometer equals, then if this is a difference in height in mercury, we can directly subtract this because this is millimeters of mercury, that's the height difference. So if the outside pressure is causing this height difference outside, and the inside is this height, the height difference is the difference in strength or force. And so for tube A, it would be the pressure of the atmosphere minus the height difference, which would be 740 minus 30 is millimeters of mercury, and we know we respect least precise decimal place, which it would be 710 millimeters of mercury here. Okay, then I bet we can tell what we're going to do here. If the inside liquid level is lower than the outside, collected over mercury, that means this inside gas is stronger. It is creating a difference in mercury of 30 millimeters greater on the inside. So we would add the height difference. Again, respecting significant figures with decimal places because we're adding. So 740 millimeters of mercury plus the 30, and we would report to the whole number, which here it would be 770 millimeters of mercury. So we are not putting a device inside to directly measure. We are measuring the pressure by a comparison to atmospheric pressure. So this lets us know what eudiometers do, how we use them, but we've just talked about mercury, and we know the toxicity of mercury. So it's not very likely that your chemistry teacher would have you collect gases over mercury. We're going to be collecting over water. And so that's what the next video will explain for us.